Good morning, my dear students. For today's video, we will be discussing on the following lessons. First, defining linear functions. Second, evaluating linear functions. And third, describing linear functions, which were taken from the Mathematics 8 Quarter 2 Module 4, titled Linear Functions by Cecil T. Duran. So at the end of the lesson, you're expected to first find the domain and range of a function, and second, graph and illustrate a linear function in its A, domain, B, range, C, table of values, D, intercepts, and E, slope. Let us have our first lesson, defining linear function. When we say linear function, it is described by the equation y equals mx plus b. Now, if you can still remember, this was presented in the previous lessons as the slope-intercept form of a linear equation. So on this equation, m and b are real numbers. M is the slope and b is the y-intercept. And always remember, for a linear function, the exponent of x must always be equal to 1. So if the exponent of x is not equal to 1, then it's not a linear function. Next, we have the word function notation. It's the equation of a linear function which is written as f of x equals mx plus b. So what's the difference between the equation presented on the previous slide with this one? It is only this one. So y is changed to f of x. This is read as f of x or f at x, the function of x. So that is the y. I repeat, y is the same as or presented as f of x. The name of the function here is f, but you can also use other symbols such as g, h, m, or n, which can be used to name functions. The first coordinate here is the x, and the second coordinate is f of x or the y. Now, given a linear function, since if we're going to graph it, what is formed is a line. Therefore, if we're going to consider its domain and range, the domain can be any number that is found on the x-axis. Or in symbols, we have d equals x such that x is an element of R or the real numbers. Take note, all numbers that are on the x and y axis of the Cartesian plane are all real numbers. And of course, for the range, we have the capital letter R is equal to y such that y is an element of R. So again, the domain and range of a linear function are elements of the real numbers. Let us have examples. What we're going to do is to determine if the given equations are linear functions or not. Here's example. F of x equals x minus 5. First, Observe that the given equation should be in the form f of x equals mx plus b. Now, since it's in that form, what you're going to do next now is to determine the exponent of x. And for this example, it's 1. Therefore, this is a linear function. Second example, f of x equals 5x. So obviously, this is in the form y equals mx plus b. So m here is 5. Take note, m is the numerical coefficient of x. So we have 5. And since we cannot see here constant, therefore, the y-intercept is 0. And the degree of x is 1, therefore, again, it's a linear function. Another example, y equals 7x minus 3. Take note, for this example, we can rewrite it to f of x because y is the same as f of x. Or obviously, it is in the form y equals mx plus b. So we have a slope and y-intercept, which are 7 and negative 3 respectively. So it's a linear function. We can also have here 7x minus y equals 5. Take note still, you can rewrite it to the form y equals mx plus b. Another example, g of x equals 2x cubed plus 9. In here, note that g of x, we can use this letter to represent the given function. But what makes it not a linear function is the exponent of x, which is 3. Next, we have f of x equals negative 8. We do not have here a variable x, but take note it's still a function and we have y. Therefore, this is still considered a linear function. But in here, since we do not have an x variable, then the slope is 0. And the y-intercept, of course, is the constant negative 8. So that's all about defining linear functions or determining if a given function is a linear function or not. Now let's proceed to lesson 2, evaluating linear functions. When we say evaluating a function, it's the process of finding the value of a function for a given value of the first coordinate x. So to evaluate a linear function, the equation must be written in the form y equals mx plus b or f of x equals mx plus b. Let us have examples. Let of x equals 5x plus 2. Evaluate the following. First, f of 3. So to evaluate f of 3, first, we consider the given function. Now, since it's already in the form f of x equals 5x plus 2, we can now substitute the given function to the given linear equation. So changing all x's to 3, we now have f of 3 equals 5 times 3 plus 2. Then, by simplifying, we now have 5 times 3, that's 15, plus 2, so we have 17. Therefore, if x equals 3, y equals 17, or f of 3 equals 17. Another example, f of negative 1. So again, Substitute, we have f of negative 1 equals 5 times negative 1 plus 2. Negative 1 times 5, that's negative 5 plus 2 is negative 3. Therefore, the value of y if the function of x is negative 1 is negative 3. Another linear function. Given g of x equals negative 2x plus 1, find first g of a. So this time, the given function or value is a letter, not a number. So what should we do? Like what we have done a while back, or we simply have to substitute a to the variable x. So we now have negative 2 times a plus 1. Simplifying, we now have negative 2a plus 1. Therefore, g of a equals negative 2a plus 1 because we cannot simplify this one anymore. Another example, g of b plus 2. By substitution, we now have g of b plus 2 equals negative 2 times b plus 2 plus 1. So we have negative 2 times b plus 2, that is negative 2b minus 4 by the distributive property, then plus 1. Combining like terms, we have negative 2b, then negative 4 plus 1, that is negative 3. Therefore, g of b plus 2 is equal to negative 2b minus 3. So that is how to evaluate linear functions. Next, we have describing linear functions. As what I have already mentioned, that the equation that describes a linear function is a linear equation. Therefore, when we graph a linear function, we have the graph of a line. However, not all linear equations describe linear functions. Let us consider the following linear equations with their graphs. So first here, since the graph of the line rises at the right, then it's a positive slope. So if we're going to give the linear equation, it's y equals, the slope is 5 yung rise, and then 3 run. That's 5 over 3. Take note, it's positive because we have here a positive slope. And the graph touches negative 5 on the y-axis. Therefore, we have 5 over 3x minus 5. Now, the second graph here is a negative slope because the graph of the line rises at the left side of the Cartesian plane. So this is a negative slope. Now if we're going to give the linear equation for this line, it's first we have to determine the slope. Rise is 1, run is 1. So it's 1 over 1 or simply 1. Since it's a negative slope, then we have negative 1. For the y-intercept, we simply have to look at the y-axis and determine which part of the y-axis did the graph touch or passes through. So it's at the point of origin. It's 0. So we have y equals negative x plus 0, or simply y equals negative x. Now for this third graph, we have a horizontal line. If it's a horizontal line, the slope is 0 because it has no rise, and whatever is the run, We have 0 divided by any number, that is 0. So the equation is y equals 4. Next, we have the last graph here. It's a vertical line. Next, we have here a vertical line graph. Now, if the graph of a line is a vertical line, that means the slope is undefined because we have rise but the run is 0. And any number divided by 0 is undefined. With the equation x equals -5. Now, of these four linear equations, only the equation x equals -5 cannot be written in the form f of x equals mx plus b or y equals mx plus b. It's because it doesn't have the variable y. That means we cannot have a function. And if we're going to use a vertical line test to test whether the graph is a function or not, it will prove us that the given graph is not a function because it will pass through, or the vertical line test will pass through infinite number of points to the given graph. Moreover, the slope of the line given the equation x equals -5 is undefined. Therefore, all linear equations in the form x equals a, where a is any number and whose graph is a vertical line, is not considered a linear function. Now, let us investigate another characteristic of linear functions using the equation or function f of x equals x plus 1. The table here shows the corresponding values of y when x equals -2, -1, 0, 1, 2. Now in here we have same differences of x. Now, considering the differences of y, or the f of x, let us observe. We have here 3 minus 2, it's 1. 2 minus 1 is 1. 1 minus 0 is 1. And 0 minus -1 is 1. So, all differences on the range, or f of x, is 1. Note that from the given equation or function, we already know that this is a linear function. Now, if we're going to consider the differences of the values for the domain and range, the table of values for a linear function shows that equal differences in x produce equal differences in f of x. Equal first differences. Let us have more examples. So given the table of values, let us determine if the given functions are linear function or not. First, we have this one. First, observe the x coordinates. -4, -3, -2, -1, and 0. So obviously, since those numbers are consecutive, then we have equal differences for x. Now let us consider the range. 3 minus 1, that's 2. 1 minus -1 is 2. -1 minus -3 is 2 again. -3 minus -5 is also 2. Therefore, all first differences of the range is 2. That means it's a linear function because the first differences of the range are the same. Next example. Now, since we have here equal differences for x, let's proceed to y. 4 minus 1, that's 3. 1 minus 0 is 1. So from these first two pairs alone, we do not have equal first differences. So we can now conclude that this is not a linear function. Next, we have this third example. So obviously, the x-coordinates here are of equal differences, like the first two examples. Now let's consider the y-coordinates. 10 minus 5, it's 5. 5 minus 0 is also 5. 0 minus negative 5 is again equal to 5. And negative 5 minus negative 10 is 5. So again, this is an example of a linear function because we have same differences on the range. Next example. These are already pure recall of what we have learned in our previous lessons, especially on graphing a linear equation using the slope-intercept form or the different parts of a graph. So identify the slope and y-intercept, then graph y equals 2x plus 3. So if we're going to recall the different steps in graphing slope-intercept form, we have to identify first the y-intercept, then plot it on the Cartesian plane. So since we have 2x plus 3, obviously the y-intercept, which is the constant, is 3. That means our first point is point 3 on the y-axis. Next, determine the slope. Then from the y-intercept, move the point. So the slope is 2. Since we have this formula for slope, which is rise over run, we will change 2 into a fraction form. So we have 2 over 1, which means the rise is 2, the run is 1. So from point 3, we have 1, 2, and the run we have 1. The slope is positive, so we move to the right, or the graph must rise at the right of the Cartesian plane. Now, we already have here 2 points. Now, connecting those 2 points, we now form a line. So, this is now the graph of the line y equals 2x plus 3. Next example. Given the graph, determine the phase, domain, and range. Now, since the given graph is obviously a line, that means it's a linear function or graph of a linear function. Therefore, the domain and the range belongs to the set of all real numbers. You can use the symbol or name it using words. For the symbol, we have this equal to the set containing x such that x is an element of R. And for y or the range, we have R is equal to y such that y is an element of the real numbers or R. And for the intercepts, we have the x-intercept first. Look at the x-axis. The point where the graph touches the x-axis is the x-intercept, so it's positive 2. For the y-intercept, it is where the graph touches the y-axis. Therefore, it's positive 1. So x-intercept is 2, y-intercept is 1. For the slope, considering any 2 points on the graph, we will count the rise and the run. Now, since we have already found the x and y intercepts, that is the easiest points, pair of points to use. So from this point, we have, or anywhere, from this point, we have the rise is 1. This one. We have 1. And the run is 2. Or we have 1, 2, that's the run. Then 1 is the rise. Using the formula for slope, rise over run, we now have 1 over negative 2 or simply negative 1 half. Another example, the equation of a line is 5x minus 4y equals 20. Determine the domain and range, the intercepts, and the slope. So from our previous example, we had determined the domain and range, intercept, and slope using the graph. Now, without the graph, but the given is the equation of a line, how are we going to find these characteristics of the line or the equation of the line? So first, let's determine the domain and range. Now, since the graph has the variables y and x, and the exponent of x is 1, then it's a linear function. Now, again, if the graph or if the line or the function is a linear function, then the domain and the range belongs to the set of real numbers. Next, for the intercepts. Using the given equation, 5x minus 4y equals 20, we will find the x-intercept, and that is by setting or letting y equals 0. Now, by substitution, we have 5x minus 4 times 0 equals 20. Negative 4 times 0 is 0, so we now have 5x equals 20. Dividing both sides by 5, we now have x equals 4. So the x-intercept here is 4. Now for the y-intercept, we will let x equals 0. Then by substitution, we now have 5 times 0 minus 4y equals 20. 5 times 0 is 0. So we have now negative 4y equals 20. Dividing both sides by negative 4, we now have y equals 20 divided by negative 4, and that is negative 5. So the y-intercept is negative 5. And last, we have now the slope. To find the slope, since it's in the standard form, we're going to rewrite the given equation in the form y equals mx plus b. So from 5x minus 4y equals 20, we will use addition property of equality. So to remove or to transfer 5x to the left side of the equation, we will add negative 5x or subtract 5x to both sides of the equation. So 5x minus 5x, they will be cancelled. So on the left side of the equation, we only have now negative 4y. Then at the right side, we have 20 minus 5x. But since we need a form of the line y in the form y equals mx plus b, the term with the variable x must come first before the constant. So we will transfer or change their position. In changing positions, but will not pass through the equal sign, the sign will follow. So we have negative 5x plus 20. Now, since we only have to have the variable y on the left side of the equation, we will get rid of the numerical coefficient of y, which is negative 4. And that is done by dividing both sides or all the terms of the equation by negative 4. So canceling negative 4, we now have y equals negative 5 divided by negative 4. Negative divided by negative is positive. Then since we cannot divide 5 over 4 exactly, so we can have 5 over 4 here. And then the variable x, then 20 divided by negative 4 is negative 5. So we already have here the equation of the line in the form y equals mx plus b. So with this, we can now easily determine the slope and the y-intercept. So the slope here is 5 over 4 and the y-intercept is negative 5. So that's all on linear functions. But before we end, always remember that for a linear function, its form is the standard its form is the slope-intercept form of the equation of a line. Y equals mx plus b, or f of x equals mx plus b, where m and b are real numbers and the exponent of x should be equal to 1. Now, for the domain and range of a linear function, it is the set of all real numbers. For the table of values, we can easily determine if the given function is a linear function or not given the table of values. That is by determining if they have equal differences in the domain that produces equal differences also in the range. And for the restrictions, all linear equations are linear functions except on the form x equals a, or the graph which is a vertical line. So that's all about linear function. I hope you have learned a lot from this video. Thank you for watching.